Welcome to the next lecture on the course Descriptive Statistics with R software. You may recall that in the earlier lecture we started a discussion on the partitioning values, and we had discussed the concept of median, and we had learned how to compute it manually and then how to do it on the R software. Now, I would like to extend this concept further. As we have seen that the median is the value in a frequency distribution which divides the total frequency into two equal parts. So, now the question is this: why only two equal parts? They can be more, they can be 4, they can be 10, they can be 100. Also, these partitioning can be equal, or these partitionings can also be unequal widths. So, now let us try to understand this concept in this lecture, and which are generally called as quantiles. So, quantiles are nothing but they are the values which try to divide the frequency distribution into different partitions. So, in case if I try to plot here the frequency distribution like this one, then we have understood that in case if I try to divide it into two parts, then this is called median. And if I say now I want to divide it into 4 equal parts, for example, this can be first part, then second part, then third part, and then here fourth part. So, you can see here this is here first part, I can denote it with here Q1, this is the second partition, I can denote it by here Q2, third partition Q3, and fourth partition Q4. And similarly, I can divide it into say here more equal parts like as 10 equal parts. I can divide it here 1, 2, 3, 4, and here 5, 6, 7, 8, 9, 10. So, this will become here first part partition, second partition, and so on. And similarly, I can increase the number of partitions also, and these partitions can be of equal widths or say unequal, right. So, in general these partitions are called as quantiles. So, just like the median partition the total frequency into two equal parts, similarly quantiles partitions the total frequency into say some other proportions, and these proportions are decided by us. So, for example, if I say 25% quantile. So, if you remember the definition of median, the median was the value which was trying to split the data into two parts such that at least 50% of the frequencies are lower than that value and 50% values are more than that value, and the value of the median. So, similarly, if I try to say here 25% quantiles, then 25% quantiles they split the data into two parts such that at least 25% of the values are less than or equal to the quantile, and at least 75% of the values are greater than or equal to that quantile. So, if I try to plot it here, it will look like this, that this is here the quantile here, so here Q, and this is the 25% part, and this is here on the right hand side, this is the 75% part. So, this is here the quantile value. And similarly, if I try to define the 50% quantile, then 50% quantile will split the data into two parts such that at least 50% of the values are less than or equal to the quantile, and at least 50% of the values are greater than or equal to the quantile. So, once again if I try to plot here the frequency distribution, then the value of the quantile is dividing the total frequency into two parts such that this part is the 50% of the total frequency, and this part with vertical sign, this is also the 50% of the total frequency. And this value which is partitioning the total frequency into two parts, this is called here as a quantile, and this is essentially the 50% quantile. And you may notice that 50% quantile is nothing but your median. So, this is the basic idea of the quantiles. So, now as we have defined the 25% quantile, 50% quantile. Similarly, I can choose any value, say 3%, 5%, 11%, 18% to 25%, 35%, 90% and so on, whatever we want. So, in general, I can extend this definition to a general definition of quantiles. So, I can say here, let me choose here the value here alpha. So, I can say here the definition of alpha into 100% quantile means if I try to choose the value of alpha between 0 and 1. So, if I take the value of here alpha to be say here 0.20, then this becomes 20% quantile. If I try to take alpha to be 0.30, then this becomes 30% quantile and so on. So, this alpha into 100% quantile is the value which divides the data in two proportion, one consisting of alpha into 100%, another partition containing the 1 minus alpha into 100%. And this division has been made in such a way such that at least alpha into 100% of the values are smaller than or less than the value of that quantile, and at least 100 into 1 minus alpha percent of the values are greater than or equal to that quantile. So, in general, if I try to plot it here, so for example, I can say here that this region consists of alpha into 100% of area, and this region with the here dots on the right hand side, this is 100 into 1 minus alpha percent area, and these are the values of the frequencies. So, this is a graph on the x and y axis like this. Sorry, this x axis is here, x axis and here y axis, and this value which is doing it here, this will be your here quantile, or more specifically alpha into 100% quantile. So, now I can choose different values of alpha. The values of alpha can be a single value, the value of alpha can be in a sequence where the values are at equal width, or the values of alpha can be a sequence where the values are different, they are not of the equal width. So, firstly, let us try to understand the basic definition of this quantile. And in order to understand this definition, means I can suggest you, please try to recall the discussion in the earlier lecture when we had discussed the concept of ordered data and unordered data. And based on that, we had defined the median for ungrouped data. Now, here in this case also, let me consider the data is given to be x1, x2, xn, and yeah, this is ungrouped data, right, and this data has been ordered. So, this value x1 is denoting the minimum value among x1, x2, xn, and this xn is denoting the largest value or the maximum value in the data, and similarly here this x2 mean the second ordered value, that is connoting the second highest value. And now, in case if you recall the definition of median for the two cases when the number of observations were odd or even, that definition is now extended to an integer n alpha. So, now the definition of the alpha quantile is the following. First, try to decide whether n alpha, this is an integer or not an integer. So, if n alpha is not an integer, then I have to choose the k which is the smallest integer greater than n alpha, and then corresponding to this value of k, try to find out the kth ordered value, and this kth value or the kth ordered value is going to provide the alpha into 100% quantile. Similarly, in case if n alpha is an integer, then the quantile is going to be the arithmetic mean of two values. one n alphath ordered value, and second n alpha plus 1th ordered value. So, both these values they can be obtained from the data, and simply try to take the arithmetic mean of these two values, and that will give you the value of the 100 into alpha quantile. So, after understanding this definition, now I can see here that just by choosing the different value of alpha, I can divide the total frequency into different number of groups. So, for example, in case if I try to choose the alpha to be here 0.25, 0.5, 0.75, and means obviously the last value of alpha will be 1, because alpha is always lying between 0 and 1. So, what essentially I am trying to do, if I try to create here the frequency distribution like this. So, I am trying to divide the entire frequency into 4 equal parts, where alpha is equal to 0.25 corresponding to 25%, the second section another 25%, third section another 25%, and another section 25%. So, these are the fourth partition. This is the first partition, this is the second partition, this is the third partition, and this is the fourth partition, and corresponding to which I can write here the values on the x axis. See here, this value to be q1, this value to be q2, this value to be q3, and whatever is here the fourth, I mean the final value, this is here q4. So, these values are called as quartiles. So, these quartiles are the values, or they are the particular values of the quantiles when the entire frequency distribution is divided into 4 equal parts, and this is connoted by q1, q2, q3 and q4. So, this q1 will connote the first quartile, which has 25% of the observations, and q2 is the second quartile, which has 50% of the observation. What does this mean? If you try to see here, my frequency distribution is like this. So, this is here first quartile and this is here second quartile. So, now if you try to see, this q2 is going to be the value which is trying to take care of entire this data. So, that is why the two values here 25% and 25%, they are added and they are corresponding to 50% of the data. So, that is why I am calling it here that the second quartile has the 50% of the observation, and this is the same as the median. And similarly, the third quartile is represented by q3 and which has 75% of the observation, and then obviously that goes without saying that the fourth quartile q4 will take care of all the 100% observation. So, now the rule is very simple. I am trying to divide the entire frequency into 4 equal parts, and those partitions will be called as quartiles, and they are the particular value of quantiles. Okay. Similarly, in case if you want to divide the total partition into 10 equal parts, for example, here we have divided in 4 equal parts, now I am changing it to 10 equal parts. Then in this case, this is called deciles. So, deciles are the values which divide the entire frequency distribution into 10 equal parts, and we denote them as here D1, D2, D10. So, this will look like this. If I have this frequency distribution, then I am trying to divide it into say 5, 6, 7, 8, 9, 10. So, this partition value on the x axis, this is here say D1, this is here D2, this is here D3 and so on, this is here D10. And every partition here, this partition, every partition will take care of only 10% of the frequency. So, I can say here that this first partition, this is trying to take care of only the 10% of the frequency. So, I am trying to decide, or I am trying to say define the D1 as the first decile which has only 10% of the observation. Similarly, when I come to the second quantile, in this case this is here D2, this is trying to take care of 10% plus 10% frequency. So, I can see here that the second decile is the value of the quantile which has 20% of the observation or 20% of the total frequency. And similarly, if you go for third, fourth and so on, similarly third decile will take care of 30% of the value, fourth will take care of the 40% of the value, fifth will take care of the 50% of the observations, and that is going to be the same as median. And similarly, the ninth decile will take care of the 90% of the observation. So, when we are trying to divide the total frequency into 10 equal parts, we call the quantiles as deciles. Now, similarly, in case if I try to divide the total frequency into 100 equal parts, like that, suppose this is my here frequency graph, and I try to make it a 1, 2, 3, 4, say here 100 partitions. So, 100 partition means every partition will take care of 1% of the total frequency. So, here it will be here denoted as here P1, P2, and the last one will be here P100. So, the percentiles are the values of quantiles which divide the given data into 100 equal parts, and they are denoted as P1, P2, P100. So, this first percentile is denoted by say P1, and this takes care of 1% of the total frequency or the 1% of the observation. Similarly, the second percentile will take care of 2% of the observation, and that is denoted by here P2. And similarly, if I try to take the 50th percentile, this will take care of the 50% of the observation, and P50 is the same as median. And similarly, if you go for the, say here 90th percentile, then this will take care of the 90% of the total frequency, and it is denoted by P90. You have heard that some of the examinations have a condition that the candidates should have obtained the marks which are lying in the top 20 percentile or top 30 percentile. What does this mean? If you try to see what is top 20 percentile, the maximum value of the percentile can be 100. So, top 20 percentile means those who are lying in the top 20 percentile, that is from 80th percentile to 100 percentile. So, what they are asking? They are saying that suppose a large number of students have appeared in the examination and they have prepared the frequency curve of the marks obtained, and now they have divided those frequencies into say here 100 equal parts. So, this first value is denoting the first percentile P1, second is denoting P2, somewhere here is P80, that is the 80th percentile, and finally, it is here P100, that is the final percentile. What they are asking is that any candidate who has scored the marks which are lying in this region, they are eligible to appear in the examination. So, that means they have got the marks which are greater than 80th percentile. So, this is the basic interpretation, and this is what they want. Now, after this let me explain how to compute these different types of quantiles in the R software. So, the basic function is here quantile, Quantile, and inside the arguments we have to give different types of thing, but the compulsion is that I have to give here a data vector, and I am denoting the data vector here as say x. Now, after this we have several options, but I am going to illustrate here the use of two props and then na.rm, and I will also discuss about type. This first parameter is going to give you the data vector of the data for which the quantiles are needed. PROBS, this is going to denote a vector of probabilities between 0 and 1. So, this is essentially the value of alpha. So, it depends which of the quantiles you want to obtain. So, by controlling the value of here this props, we can generate different types of quantiles like as quartiles, deciles, percentiles or something else. Third option is na.rm, that we know that in case if there are missing values in the data, then if I say that na.rm is equal to true, then the quantiles will be computed on the basis of the data that is available inside the vector x. After this, there is another parameter here, type. Type is going to take a value between 1 and 9. That can be 1, 2, 3, 4, 5, 6, 7, 8 or 9. And this is going to inform the quantile command that which of the 9 available algorithms to compute the quantiles is to be used. What does this mean? Well, you see, once we have got the data has to be ordered using some algorithm, and then based on that the algorithm has to partition the values, and then the algorithm needs to choose the correct value of the quantile. So, all these things, this entire process is based on certain algorithms. Different people have given different types of algorithm to compute the quantiles. And it is possible that when we try to compute the quantiles based on different algorithms, their values may differ little bit. But that is essentially the choice of the experimenter or those who want to compute it, that which of the algorithm they want to use. So, this R has this facility that you can choose say any of the algorithm that is available inside R software to compute the quantiles. Okay. So, for example, if I say type 1, means it is something like I will type is equal to 1. Then this is going to use the algorithm based on the concept of inverse of empirical distribution function. If you choose type equal to 2, this is similar to type 1, but here in this case the averaging has been done at the points of discontinuities. And similarly, if you choose type equal to 3, then this is based on the nearest even order statistics. But definitely I am not going to discuss these type of algorithms here, but my simple objective is this, how to use them on the given set of data. So, now I will try to take here an example, and I will try to show you that how you can compute the quantiles, or in particular quartiles, deciles, percentiles or anything else. So, now I consider the example which I also had considered earlier, that there is a data on the heights of 50 persons which are recorded in centimeters, and this data has been stored inside a variable here height, and now we would like to compute different types of quantiles over this data. So, when I say quantile and here height, the height has to be the data vector which has to be given inside the arguments brackets, and this is here the outcome. You can see here there are two rows. First row is this one. So, it is trying to show 0%, 25%, 50%, 75% and 100%. And just below this there are values here 121.0, 137.5, 146.5, 158.0 and 166.0. So, this is indicating the value of the quartile at 0%. And then the second value is connoting the value at the 25%. Third value is denoting the value 146.5 at 50% quantile. This 75% value is indicating the value 158.0. So, this is indicating the 75 or 75th quantile, and this is indicating the last value is indicating the 100th quantile, whose value is 166. So, essentially if you try to see here, this value is indicating the first quartile Q1, this is indicating the second quartile Q2, and this is third value is indicating the third quartile Q3, and Q4 is the last value, which is the value of the fourth quartile. So, you can see here this is also the value of the median, and this will also be same as the value of P50 or say D5. Right. So, what you have to observe here, that when you are trying to use the command quantile, then the default option here is quartiles. Now, in case if you want to find out other things like as deciles and percentile, then you simply have to control the parameter props. But here I would like to show you, before I go to deciles or percentile, that in case if I try to choose the props here to be a sequence between or sequence from starting from 0 to 1 at an interval of 0.25. So, this command seq, it is going to create a data vector like 0.0, 0.25, 0.5, 0.75 and 1. So, now I am asking to compute the quantile of the data in the height vector using the probabilities which are here. So, you can see here the outcome will look like this. And now, what you have to understand that how the things are happening. This 0%, this is the same as this 0.00. This 25% is the same as 0.25, the second value in the props vector. 50% is the same as 0.5, which is the third value in the props vector. 75% is the same as the value 0.75, which is the fourth value in the props vector, and 100% is the last value 1.00 in the props vector. And you can see here that these are the values of the quantiles, and essentially if you try to see, they are the quartiles. So, you can compare these values and the values which you have obtained directly by using the quantile, they are the same. And this is here the screenshot of which I will try to show you on the R console. So, let me try to first copy the data on the R console. So, you can see here this is here the height data, and I am simply trying to find here quantile of here height, right, and this is giving me the this value. And if I try to use here my this props or the sequence of between 0 to 1 at an interval of 0.25, you can see here that these values are the same values which are here, right. Okay. Now, after this I try to show you that how you would try to find out the other types of quantiles like as percentile and deciles. So, first we try to understand how to generate or how to compute deciles. So, now you have understood, it is very simple, the command is the same. What you have to do, you simply have to change the props vector or the data inside the props vector. So, deciles are essentially controlling the value of alpha to be as 0.1, 0.2 up to here 0.9. So, I simply have to generate here a sequence from starting from 0 and ending at 1 at an interval of 0.1. So, using the command seq, I generate such a sequence, and this value is coming out to be here like this, you can see here. And now, I simply use the same command which I used earlier, but in this case I have simply replaced the value 0.25 earlier to now 0.10. And you can see here I am getting the 10 value of the deciles. So, for example, as we have explained earlier, this 0% is corresponding to 0.00, 10% is corresponding to 0.1, 20% is corresponding to 0.2, and similarly here 100% is corresponding to 1. And these are the values of say this here D1, D2, D10. This is here D1, this is here D2, this is here D3, D4, D5, D6, D7, D8, D9 and here D10. Right. So, these are the values of deciles, and similarly this is here the screenshot. I will show you on the screen also. Now, we try to compute the percentiles P1, P2, P100. So, now it is pretty simple. I simply have to generate a sequence from 0 to 1 at an interval of 0.01. So, I try to generate this sequence, and you can see here these are the values which are obtained here 0, 0.0, 0.01, 0.02 up to here 1. So, now just using the earlier command means I generate the quantile. So, I simply have replace the value in the props by here point is 0, 1, and you can see here that the values of all 100 percentiles they have been obtained. For example, this is the value of first percentile, this is the value of second percentile, this is the value of third percentile, and similarly in the last this is the value of here 99 percentile and this is the value of here 100 percentile. Similarly, in case if an examination needs that the candidates must have the marks more than 80th percentile, then this is going to be controlled by this 80% and the P80 here is 159. So, this means the candidate needs to have marks more than 159. Now, before I go further, let me try to show you these things on the R console. So, I try to compute here the deciles. You can see here that they are the can value, and similarly if I try to change here only the last value, then this will give me 100 values which are here the percentiles, and they have been presented on the slide. So, let me come back to my slide. Now, I will try to continue with the same example, and I will try to show you that in case if the data is missing, then how we are going to compute the quantile. So, I have replaced the first two data values by here NA, and I have stored this data into height dot NA here as we have done it earlier. And now, I will try to compute the same thing whatever we had compute for this height dot NA. So, you can see here as soon as I give here only the quantile function without any specification of NA dot rm, this will give me an error. Right. And so, I try to add in the quantile command NA dot rm is equal to true, and this gives me this data, that is the first quartile, second quartile, third quartile and fourth quartile. Right. And similarly, in case if I want to find out the deciles in the same data, I have to use the same command here, and I have to use the props, which is the sequence of 0 to 1 at an interval of 0.1. So, this will give me the deciles. So, you can see here these are the deciles that we have obtained, and this is the screenshot of the same operation which I just shown you. And now, I will try to show you this thing on the R console to make you confident. So, I try to store this data as say here height dot NA. So, you can see here this is my here height dot NA, and if I try to find out the quantiles of height dot NA, this will give me an error. So, now I have to add here that NA dot rm is equal to true, and this will give me the values of the quartiles. And similarly, in case if I want to find out say deciles, then I have to add here the function props is equal to sequence starting from 0 to 1 at an interval of 0.1, which is here like this. So, you can see here this is here the deciles. And similarly, in case if you want to compute here percentiles, in this case you simply have to change this value to be here 0.01. Okay, you can see here these are the different percentile. Now, I would like to show you that in case if you want to compute some other percentiles which are not in the equal width, suppose I want to compute here the 14th percentile. So, I will try to give it here the value 0.14. Suppose I want to compute the 23rd percentile. So, I will try to give it here the value as 0.23. Suppose I want to compute the 79th percentile. So, I will try to give it the value here 0.79. Okay. And now, if I try to write down here quantile of the data heights and with props given by here the above. So, you can see here you are getting here the 14%, 23rd percent and 79% percentile. So, this way actually you can compute different types of percentile, and if you learn statistics there is a topic say testing of hypothesis where we define the level of significance. Those the definition of level of significance is nothing but is related to computing a particular percentile. So, this concept is going to be very useful for you when you go for further courses in statistics. So, I would like to stop here, and I would once again request you to look into this concept, try to practice them on the R software, and we will see in the next lecture again. See you and goodbye.